Hi, welcome to the last episode of this series, Survival Analysis. In this particular episode, we are going to be looking at how to build survival model using the library Pysurvival on Python, and we are going to also be looking at how to use best practices to deploy survival models. So we have a guest in the house, Lawrence Okekbemi. So Lawrence is going to be taking us through best practices on how to deploy survival models. Lawrence is a machine learning engineer. Lawrence is very good at what he does. Trust me, he's a very smart guy. And also you have Eniola. Eniola is a data scientist here. He's going to also take you through how to build survival models. Also, we are going to be going through a basic intro of what survival analysis is. So if you need a more basic or a more solid introduction of survival analysis, you can check out our first video on it. So what is survival analysis? Survival analysis is actually a statistical method in which you use to study the time to an event. So the term survival most times suggests that the event of interest is death, but it can be applied in other area of interest also. So for example, you want to know the time a machine will lose its efficiency, also we can use survival analysis for that. So these are some libraries in which you can build survival models with. We can use Liveline, we can use Scikit, we can use Scikit Survivor, and we can also use Pysurvival. But for this particular one we are going to be using Pysurvival to build our survival model. So Pysurvival is an open source Python package so for survival analysis modeling. So the modeling concept used to analyze or predict when an event is likely to happen. So it is built on NumPy, SciPy, and PyTorch. So it is compatible for both Python 2.7 and 3.7. So to use Pysurvival, it's as simple as installing it with this method. You just do pip install Pysurvival on either your terminal or your notebook, and you are ready to use Pysurvival to build survival models. Our case study for the survival model we are going to be building is customer churn prediction. So we are going to be seeing how we can leverage survival models to predict when a customer will churn or not. So if you have gone through previous video, you are going to know that for survival model, we usually have two target variables. So the first one is the event. So in this, our particular case is whether the customer have churn or not, which will be 1 or 0. Then also the time to event, the time dimension. For this particular case, the time to event is month active. So when a particular customer is active, the time in which the customer is active or not. In Pysurvival, we actually have 3 types of survival forest model. So the first one is conditional survival forest, the second one is extra survival tree, and the third one is random survival forest. For the survival model we are going to be building with Pysurvival, we are going to be using conditional survival forest because of the kind of accuracy it gives. It outperforms extra survival trees and random survival forests. So censoring is usually one of the reasons why we use survival models. Other conventional models like logistic regression, linear regression, they do not take into account if a particular data is censored or not. So for this particular case, we are looking at if a customer will churn or not. So if you look at this scenario here, when the data set has reached the end of the observation period and some customer will not have churned, so that's an example of censorship. So if you want to understand what censoring is in more details, you can check episode 2 of this series. So to undo censoring issues, survival model use a modified configuration. Usually if you want to build a machine learning model, you just need 2 arrays, that is X and Y. So X represent the features in which you want to use to train, and Y represent your target variable. But with survival model, we usually have 3 variables. We have X, we have E, and we have T. S is the array in which you use to train the variable. E is the event of interest, and T is the time to event. So we usually have 2 targets here, the event of interest and the time to event. So basically, survival model predicts the probability that the event of interest will happen at a particular time T. So we usually use 2 accuracy metrics to check how our model is performing. The first one is the concordance index. So the closer to 1, the better your model, and we usually use the Brier score. The closer to 0 also, the better our model. All right, so I'm going to be taking you through how to use Pysurvival to build survival model. We are going to be using Colab. Colab is a Jupyter notebook on Google Cloud. So you can use any other environment in which you are comfortable with, either your Jupyter notebook offline or in any environment suitable for you. So first thing we need to do is to install Pysurvival. So this is how we install it. Pip install Pysurvival and you are good to go. Then after that, we install the libraries we are going to be using for our modeling. So here I'm going to be using pandas, numpy, matplot library for plotting graphs. Then also, this is how we import the Pysurvival tools we are going to be using. So Pysurvival has a built-in data set, which is the Sean model we are going to be building, and see how to model survival models with it. We are going to be using the data set on top of Pysurvival. So I'll just run this. So a brief run through about the data set again. So we have the event, which in our own case is the Sean. If you check the data head, this is the event we are trying to predict Sean, and also the time to event, which is the month active. So basically what we are trying to do here is to see like what particular month a user is going to Sean. That is what we are trying to model using survival analysis. So we want to see based on the month active. So for a particular user, can be 2, it can be 1, can be 3. Let's just check it. So I'm going to be checking the unique month active. So I'm just going to be saying df0.monthActive.unique. So we can see we have 3 months, 2 months, 7 months, 8 months. The highest is 12 months actually. So we want to use survival model to predict the time a user will Sean, the time a user is going to Sean. So basically, conventional model will just predict if a user will Sean or not. But with survival model, you can tell the time in which the user is going to Sean. So after that, I check what I'm doing here is just trying to check if a particular column contains missing value or not. So there's no missing value, so I can just move on. So I created a helper function here to plot numerical variables and see. So I'm just going to do it here. I'm going to uncomment this and we check the plot of some numerical variables. So we can see box plots and the histogram plots here. So this is just to see the distribution of our numerical variable. Then we just move. So I'm installing Feature Engine here. Feature Engine will be used to encode some of the categorical features we have. So we have about 1, 2, 3, 4, 5. We have 5 categorical features. So I'm going to be using one-hot encoder in Feature Engine to encode this categorical feature. So after encoding, this is what I have. The code is going to be uploaded on GitHub. So I'm going to share the link. So no worries about that. So after label encoding and the whole preprocessing, I'm trying to get my data set ready for survival model. This is what I have. So now I can now build my survival model for this particular data set. So first thing I need to do is from Pysurvival, I need to import the metric I'll be using. So I'll be using the concordance index and the Brier score. Then also the model I'm going to be using, the survival forest model. I'm going to be using the conditional survival forest model for the model we are going to be building. So after this, I need to separate the event and the time to event target variables from the array of features we are going to be using to train our model. So I have the time column here, which is months active, then the event column, which is churned. So I just need to separate them from the main feature. So I created a variable called X to store the features there. So I'll just run this. Invalid. Okay, there's an error. df1 is not defined. Okay, I created a copy of df1. It should work now. Yeah, so these are the arrays of feature I'm going to be using to build the survival model. So what I'm just trying to do here is just check the correlation of features that I want to use to build my survival model. Then after this, I split my data set into train, test. So what I'm just doing here is just trying to split. So I have my train set and my test size. So the test set is just 35% of the whole data set, and the train size will be 75%. Sorry, 65%. So after that, if you remember, we have 3 variables we are going to be working with for survival model. So we are going to be working with the X. The X is the array of feature you are going to be training with. Then you are going to be working with T. T is the time to event, and also E. E is the event of interest. So we are going to be separating the train set from the test set also. Then we are going to be separating the time to event for both train and test, then also the event for both train and test. Then after this, I just create an instance of the model. So I create an instance of conditional survival forest model. Then I set a parameter of number of trees to just 200. Then after this, I just need to fit my model. So if you are fitting your model, you put your S train, your time to event, and the event of our interest, which is churned. Then you can specify some other hyperparameters you want to set. So we have mass feature here, we have mass depth, and different ones. So this is the basic way we fit a survival model using Pysurvival. So I'm using a conditional survival forest model for this particular model I'm building. So after this, now I can now test and see how my model is performing on the test set. So this is where the concordance index come in. So I just take the concordance index from Pysurvival. This is it. So I'll just call it from here. So if you are calling it, you need to set the model. So we are using the conditional survival forest model here. Then you need to tell it which particular data set you want to test for. So we separated our S test, so we are testing for this. Then we also specify the T test, which is the time to event, then the event also. So once you run this, it will give you a score. So this is 0.84. So the closer to 1, the better the accuracy score, the better the concordance index score. So our model is performing well with this 0.84. So another metrics we can use to evaluate the performance of our model is the Bragg score. So what the Bragg score does is that it outputs the accuracy of a particular survival function with respect to a particular time t. So if you look at this diagram below, you can see on the x-axis we have 0 to 12. So this 0 to 12 represent the month active. For this particular case, we are trying to predict the churn rate, and we have 2 target features. We have the event, which is churn or not, then we have the time to event. So the diagram below is showing the integrated Bragg score plots, which outputs for their different respective time the Bragg score. So if you look at the time below here, which is 2, for 2 you are going to trace it up and you see the Bragg score. So the Bragg score is a way to see our model is performing at a particular time. So to calculate the total Bragg score, is we have the integrated Bragg score. This computes the total, the overall Bragg score for the test set, which is 0.13. So a model is considered good, or is considered good or okay if the Bragg score is less than 0.25. So that is all for this. Then we move to deploying this model by Lawrence. Yeah. All right, so we have Lawrence in the house. Lawrence is going to be taking us through how to deploy our code, our survival model to production. So I'll just leave it to Lawrence now.
All right, thanks, Benny. Hi, everyone. Welcome to this section where we're going to be talking about how to productionize our survival model, which NLR has been talking about for some times now. Okay, and in this section, basically, we are going to be using Fast API in order to create the model endpoint we are going to be using. We are going to talk about reproducibility and, of course, versioning with Git and Docker. We're going to actually create our infrastructure using Terraform Terraform is a tool that is very popular for infrastructure as code, and we are going to be creating all of these infrastructures on Microsoft Azure platform. And at the end of the day, we are going to actually see how easy it is to create infrastructures with Terraform on Microsoft Azure. And at the same time, we are going to see how Fast API really help us in order to also generate a kind of automatic documentation. And at the same time, with the help of Pydantic, we're going to see how to do a kind of validation for the payload, all right, that comes into our model for prediction. Okay, code is already on GitHub. I'll just begin to go to GitHub and we'll clone the repository to start. These are the steps we are going to be taking. We are going to talk about scripting and packaging, like I mentioned, version and reproducibility, infrastructure provisioning with Terraform, and of course, we are going to productionize or go into production. We are going to use Nginx. I didn't talk about Nginx for reverse proxy. So all of these things are what we are going to set up using Terraform. Okay, let's get to it. I will be sharing the link to this code. So this is actually the repository we created for this. And as you can see, it actually consists of quite a couple of folders and actually some files that will really help us to productionize our survival model. All right, if you're on Linux, if you're on Mac, or if you're on Windows, you can switch to your command prompt or maybe your Git bash. If you're on Linux or Mac, you can just open your terminal. And so first thing I want to do is I want to check my current directory. From here, I can actually just make a new directory. Let me call it survival model. That was what I used when I was doing the dry run. Now I've actually created a directory called survival modeling. I'm just going to switch to that directory using my cd command. Survival analysis. Survival modeling. Yeah. Okay. So now I'm actually in this folder. It is clear, nothing is there. So I can actually clone this repository right here. So let me copy the link and come back to this page. So I'm going to use git clone. Make sure you have git before you run this code. You have git installed already. So I just want to do it once again. Git clone, and I'm going to paste this. So let's wait till this finished cloning. We're going to let's move forward right from there. Okay, let's give it a few more seconds. Okay, why this is actually getting cloned, once it is done, we are going to open our Visual Studio Code. So make sure you have an editor, like a code editor. Let me say, if you are not using Visual Studio Code, it's fine. You can use Sublime, you can use Python, you can use any environment that you are comfortable with when it comes to your Python development. So it's not, you can use any other package if you like. Okay. Let's give this few more seconds to finish downloading. It's not heavy, but I guess it's just my internet. It's not that much. Okay, let me just stop this and retry it again. It shouldn't take time. I don't know why it's taking this long time. All right, so this is done downloading. Let me confirm that the folder are successfully downloaded. I'll do ls. So now here is our survival analysis folder, which we actually cloned from GitHub. Okay, so let me just cd into the repository, the folder. Okay, now I can do ls, and now we can actually see the files that we currently have in our repository already downloaded right here. So we can actually go ahead now and launch our Visual Studio Code. So I'm just going to do code dot. This is actually a way to make sure that I open the Visual Studio Code with this folder opened already for me. Now the other way is I can just go to my Visual Studio Code and open the folder manually. Okay, but this is just like more or less like the faster way of doing that. So I'll just do code dot. If you are on Linux and on Mac, this should work for as well, but for Windows I think it's quite different. I don't know for that. Okay, so now you can see that the folder has actually got opened in our VS Code. I'll just make sure that I make this bigger, and yeah, so we have this clean working environment with our folders and some of our files right here. Now you can see this properly. Let me still zoom in a bit. Yeah, so this is better now. Okay, now if you've been following, you actually notice that Daniela has dealt with this part where he walked you through his code. So what we are going to be doing in this first section is actually to convert his notebook to a script, and we are going to like just do packaging for it, and at the same time we are going to create an endpoint, like I mentioned, using fast API. Okay, so when you take a look at this notebook, so let me split my screen. Okay, I'll just open this. Just open this right here. I want to make it okay. Now, basically, what I did, or the first thing we are going to do is actually to install Pysurvival. Now, in order for you to install Pysurvival, I would really advise that you follow through the Pysurvival installation guide, which is provided for you when you just go to Pysurvival. Okay, just go to Pysurvival, maybe documentation. Okay, so just type this, and when you get to Google, that should be like the first thing that comes on your Google search. So make sure you come to this place, and now first thing I need to make known to you is the fact that Pysurvival works best, okay, for Python 2.7 to Python 3.7. I know that's like a bit old, but at least Python 3.7 is still something I would really advise to use because of other libraries we are going to be using. Now, if you're on Mac, you can follow this installation guide. Don't forget it needs C++ compiler, and for a lot of people who might be having issues with this, just follow this installation guide. If you're on Linux, you can follow this. If you are on, if you want to follow, or maybe just using the PyPy library, you do this. But first of all, make sure you have the C++ compiler before using or before doing this pip install Pysurvival, so that you don't run into some issues. Now, in order for you to, or if you notice that this is giving you too much difficulty, we are going to talk about how you can actually use Docker. All right, we are going to talk about how you can install this in a Docker container, and how you can run your Pysurvival in a Docker container rather than having to like install this manually, because you might run into some couple of issues which I actually ran into. Okay, so installing Pysurvival is very easy. Just follow that procedure I showed you. Okay, let me close this notebook, and we are going to be talking about this script. So there is main.py. In the folder we cloned from GitHub, you actually notice that there is a subfolder, churn, right? Still in this root directory, you notice there's a folder called churn. Churn actually has four files, four scripts, which you can open each of them one after the other, and you're going to see. I'm going to just like rush through each of them to actually give you an idea. It's still the same thing as what you have in the survival analysis notebook. So I just basically like copied most of them and formatted properly so that it's modular, just modularize it. That was what I did. The first thing I'm going to talk about is the preprocessing part. Now, the only thing that seems different from the notebook where NLR actually trained the model is that instead of using scikit-learn for our one-not encoder, I'm using feature engine, right? Now, the reason I'm using feature engine is because feature engine, after performing the transformation, it still returns back a pandas data frame rather than just arrays unlike scikit-learn. So it's very easy for me to handle, and that's why I decided to go with feature engine. It's a very popular library as well, which is actually meant for preprocessing. So it has a lot of packages included, a lot of transformers that you can actually use for your data set. Now, you are only using one-not encoder from feature engine. Now, if you go through this code, so I actually define a function which is one-not encoder, which takes in a pandas data frame. It performs so these are the categorical data or the categorical columns we are dealing with. Product travel expense, product payroll, product accounting, and company size, US region. Basically, these are the categorical features, and I actually just used the one-not encoder we imported from feature engine in order to perform the encoding. Then I'm actually fitting it. So here what I did was to just define the one-not encoder object, and I'm actually calling .fit on the data which will be passing into this function. And at the end of the day, I'm also transforming it, and I'm returning the encoded data. The encoded data will be our data frame plus the encoded columns, right? Then I define another function called data splitter. Now, the essence of this function is actually just to split the data into X-train, X-test, of course, T-train, T-test, E-train, and E-test. Just the way we know that this is quite different from the classical machine learning we've been dealing with. This actually takes into account three different variables that are very, very important, which NLR has explained in previous videos. If you've not checked it out, I would suggest you actually check out those videos first, where you actually do the kind of very explanation before coming down to this. It's very straightforward. All of these codes, once again, are included in NLR's notebook, which he has actually talked about. What I'm returning from this data splitter function, which you can see, is the X-train, T-train, E-train, then the testing. So just splitting the data into training and validation sets, basically nothing too difficult or too complex here. Okay, so that's everything I'm doing under the preprocessing. For the train.py, now I'm actually importing, of course, still importing our NumPy pandas. Actually importing save model and load model from utils from utils in Pysurvival. This save model will help us to save our model. This load model will help us to load our model again for evaluation. Now, if you're coming from scikit-learn knowledge or from scikit-learn perspective, you might actually be using something like JobLead, okay, or maybe you want to fit with the model. Nowadays, a lot of people use JobLead, and the reason is because of the way JobLead actually helps you to handle your model, the way to realize your model and the way to realize your model. Okay, and of course, Concordance Index or integrated or real score, just like NLR has explained, Okay, so we are actually importing all of these things to be able to evaluate our model, and at the same time to be able to get our model performance, to be able to understand our model performance. Now the only thing you have right here is just a class. Okay, just a class. We only have a class, or a class named trainer, and we have some couple of methods defined. Just two methods defined, basically. Right here we have our model, and for this our training step method, okay, we are passing in our x, we are passing our t, our e, and our model artifact part. Okay, I'll tell you the reason we are actually passing this as an argument. Okay, now the reason we are passing this artifact part as an argument is because we want to be able to save our model to that part. So first of all, we need to tell when defining our training step, we need to tell where exactly we want this model to be saved to. And if you check this root folder, all right, you actually see that there is artifacts, there's an artifact folder. Okay, so that's the part at the end of the day which I'll be passing to this training step. Okay, moving on. So as you can see, what I'm actually returning is that model finish training. So essentially what this thing is doing is just to train our model with some of these parameters which we've defined. In later videos, okay, maybe we might be dealing with something like things like model tracking, things like experiment tracking, basically, where maybe we want to do things on optimization. All right, all of these things, we might not be passing them in as raw values like this, or we might not be coding this. We might just be like, we might have some sort of values we want to just see their estimate their performance. So they will be actually passed into this function dynamically, not hard coded this way. Okay, the next, which is like the last method in this this trainer class, is eval step. This eval step essentially just evaluates the performance of the model we train using this method. As you can see, I'm still passing the artifact part. Of course, I'm passing x, t, and e as well. The first thing I'm doing here is to load the model. Of course, using the concordance index we imported, we're actually calculating the performance right here. And right here, we're actually looking at integrated Breyer score. At the same time, once this is done, actually outputting this concordance index and the integrated Breyer score. That's everything I'm doing under this eval step. Very simple. Still the same thing as what you will find in ANALYSIS notebook. I actually just put the notebook under experiment in this root folder. Okay, so let me open this again. And what we've not talked about is predict.py and main.py. Now, quickly, let me talk about this predict.py. The predict.py is the one that will be responsible for helping us take in our test data, right? And using that test data and the artifact part, okay, to actually predict, just to predict the test data. So that's what this get prediction function, which is like the only function in our predict.py is helping us to do. Okay, I'm loading the model once again using artifact part and this load model function, which is actually defined or which comes with our Pysurvival with use. Now, these are t values that were just hard coded. Okay, if you go through ANALYSIS notebook, you actually find this as well. We can make this to be dynamic. We can make this as well to be part of the arguments we are passing into this function. But just for demonstration's sake, okay, that's why we are hard coding some of these things here. And at the end of the day, what we are doing is to like predict survival. Okay, we are taking the values of x and we are using t. So for each of these t, okay, we are actually predicting the SVF. Okay. At the end of the day, we have a column called risk, right? Where we are also predicting the risk. So what we are returning is actually the x. The x now contains the values which are the x values and our SVF as well as our risk. Okay, so basically these are what we are predicting, and that's what we will output using this get prediction function. Okay, now going to the last script we have under this churn folder before we move to another step. So this main.py is where the whole magic happens. This is where the whole thing on training happens. Okay, if I want to train the model, I will just need to run this main.py because I'm actually importing. If you notice, I'm importing train, I'm importing preprocess. Okay, of course, import pandas. I'm importing path from pathlib, and at the same time, these are model. We are using conditional survival forest model. Okay, so this is actually the model we are using for our prediction. Now, the first thing I'm doing right here, this might seem a bit, maybe some people might not be used to it, but what I'm actually doing by using this function is to get the root folder for my project. Okay, that's what I'm using this thing or this function to do. This get project root. I'm using to get the root of my project. That is this directory. That's what I'm using. So I'm using to get this directory. Okay. What I'm doing right here, this training function. Basically, this script only contains two functions, and where we have our if statement to run this script once I actually call main.py, Python main.py in my terminal to run. So the second function which I actually defined here is the training. Now the training takes in the data and the artifact part. The artifact part hasn't changed. It's still this folder I'm referring to. Okay. First thing I want to do to my data is, of course, I want to encode my data using one-hot encoder which I define in preprocess. Okay, this preprocess file actually define this function one-hot encoder. So I'm passing in my data. At the end of the day, I'm getting an encoded data. If you go back to our preprocess, you actually see that what we are getting back is encoded data. Okay, these are one-hot encoder function which we are talking about right here. Okay, now I'm doing my extrain. I'm splitting my data now using the data splitter function, which I defined right here. Okay, as you can see, we are returning these values, and that's what we are equating to our preprocess dot data splitter. Okay, we are defining our model, and at the same time the trainer. So we call the trainer class from the train.py, and we are passing in our model. Okay, that's the only thing we need to instantiate the train object. Okay, then we call our train step where we pass in our data that we've splitted from this. So we pass in our X train, T train, and E train first because we want to actually carry out the training. Then we talk about, we also pass in the artifact part. Then we talk about the evaluation. So the evaluation is what we call the eval step from the trainer, okay, which is still like this object. It's still part of this object which we define using our trainer class from our train.py. Okay, at the end of the day, we'll just return the scores because what this eval step actually returns is our score. If you remember, it returns. Okay, it returns our confounders index and integrated Boolean score. Okay. And at the end of the day, what actually doing in order to wrap this up is, so I'm actually getting the project base using the get project root function I defined right here. And of course, I'm also defining the artifact part. So I'm defining the artifact part right here. I'm also defining the data part right here. So this part, the join part, is just to like concatenate together my project base and where my pointing to where my data actually is. Please don't put / here. It's going to it's not going to work. Okay, so just forward it like this. That's how to use our join part. Okay. So I'm actually reading in the data and I'm performing the data training and evaluation right here. Okay, so that's basically what I'm doing. Now, before you go ahead to run this code, the first thing you are going to do is, let me open my terminal once again. Okay, in order for us to see that this actually works as expected. Okay, let me see if I'm still in this folder. Okay, I'm still in this folder. If you are using Python, what you want to do is to run Python, you create a virtual environment. Okay, you do this. Okay, so it's create a virtual environment. Let's give it a few more seconds to finish creating our virtual environment. Okay. Once it's done creating the virtual environment, before we do any other thing, now it's done, you just have to do source venv bin activate, right, in order to activate the virtual environment. Now we are in the virtual environment. Okay, in order for us to run this code, make sure you have Pysurvival installed. So that's like the first thing you want to do. You want to do follow this guide right here to install. First of all, install your C++ compiler. Make sure you have it. If you're on Mac, if you're on Linux, or the instructions that are written here. Now, at the end of the day, you can now come to do your pip install Pysurvival. Okay, I'm not going to carry out that step because I want us to actually use Docker in order to train this model. So we are going to continue from there to use Docker to train the model, which is more or less like another thing. In case it's giving you a problem, you can actually train this model in a Docker container, train the model, do the output, and at the end of the day, or you can perform inference using the same Docker container. Okay, and you can now still deploy that same Docker container you are using for inference. Okay, so which means that you must have some or your app, which is this app, okay, where we have the fast API in there. You must actually wrap it up everything inside the container. What we are going to be using for our Docker container, we have our Docker file, okay, and we also have our Docker compose file, which are going to be using to spin the container. Okay, so make sure you actually in this survival analysis, or you create a virtual environment in case you want to do your pip or pip install Pysurvival. Like I said, this pip Pysurvival is a bit heavy because it's dependent on Torch. So it's going to install Torch and it's going to install some couple of other packages. For you to know, or maybe just if you are following this, make sure you can just do pip, or you can just install these requirements. I've actually exported this requirements file, which helps you to install every packages you are going to be needing to successfully run everything we have in this folder here. Okay, the two other libraries, or let me say two other packages that are important will be Docker and Docker Compose, and at the same time Terraform, because we are going to get to that shortly. Okay, and I think that's all about scripting. Okay, let me talk about scripting. Now, in order for us to create an endpoint, so we are utilizing fast API. Now, if you come to this app folder, you notice that I have two files. Basically, I have API and I have schemas. Now, for schemas, the reason we are, with the help of Python, okay, I'm actually defining the values I'm expecting to be passed into the model. And the reason I'm doing this is just to avoid some sort of wrong data coming into the model. All right, so I am already defining the kind of data I want to be passed inside my model already. So this is actually a good thing to have in your model, or while deploying, to make sure that any data is not just being passed into your model. Okay, you have so what I'm just doing is data validation, basically with Python. So we are defining the schema for that data. Then the next one will be our API. Okay, so So the API, basically, if you watch this, I'm just importing some couple of steps from Fast API. If you are not used to Fast API, I would recommend you check out the documentation. The documentation is really good for every starter. It's like a go-to material. Okay, I'm importing parts from Pathlead again, OS, and of course my schemas and pandas. Now I'm also importing preprocess from Chon because I want to use the same function which I actually use for preprocessing my training data. All right, I want to use that same function, and I also want to import get prediction from my predict folder, which is this predict.py. Okay, I'm doing the same thing here. I'm getting the root or the project base. That's like the project root. That's what I'm getting here. So I'm actually instantiating the function, and I'm creating a Fast API object app, and I'm defining the artifact part and the data part as well. Now there are just two how I call them, two endpoints basically right here. So you have your root endpoint, and you also have the predict endpoint. Okay, the predict endpoint is where the prediction happens. That's where you pass in your payload, your survivor payload. Okay, the survivor payload is actually being defined by these schemas. So if you pass in any data that the model is not expecting, it's going to throw you an error that you've actually passed in the wrong data. Okay, and if you get to /, which is like the root, the home page of, you are going to see this Pysurvival training prediction. Okay, so now for us to kickstart, I can basically just do, if you do pip install and you install all of these requirements. Okay, once you've done that, I don't want to do that because it's going to take a while. The Pysurvival takes some time to get installed. But once you've been able to install it and you want to actually run this part, make sure you are running this part, this app API.py. Make sure you are running this API.py once you've actually trained your model. So the first code you are going to want to run after you install everything will be Python. You are going to want to do, okay, maybe you want to seed into Chon first. You have ls, then you can do Python. Make sure you have Python 3.7. Make sure you're using Python 3.7 if you want, or if you don't want to really encounter some issues. Okay, I've actually used PyEnv to install Python 3.7 on my PC. All right, so moving on from where we left off, now we are going to be talking about the reproducibility part, and we're going to be putting this in the Docker container. Docker container really has a lot of benefits, okay, when it comes to helping you to reproduce your work across several teams. You know, maybe when you work with different teams, so it's really a good practice to use Docker, even software-wise, and coming to the machine learning space. It's something that is really going to save you a lot. Now, for instance, if you've been having issues with getting Pysurvival installed, I would just advise you to just make sure you have installed Docker on your PC, and with Docker, okay, you can actually train the model like I mentioned earlier on in this section. You can just train your model with Docker and at the same time carry out your inference with Docker as well. Now, I've actually structured this code to perform inference with Docker, okay, not to train the model. Okay, when I was training the model, I actually used this entry point Python chon main.py to actually train the model. Now let's walk through this Docker file from the very beginning. I'm actually using this official Python to like just set up my environment. The first thing I'm doing is to run this apt-get update to actually update to update the environment, and at the same time I'm actually installing some of these build essentials dev GCC which are the C++ compilers. Okay, at the same time I'm actually removing this thing. This is a good practice because I don't want this to actually produce to get to the next layer. So they are not really relevant again, because it's just going to make my image so big. So the best thing for me to do is just to take it off. This is actually a good practice, especially when you work with Docker in Python. Okay, now I'm setting the environment. Just if you follow through this tutorial, through this guide, right here, if you follow through this guide, okay, you actually see they ask us to export CXX and C. So coming back to this page, that's what I'm actually doing. I'm actually exporting. So I'm setting this as environment variable in our Docker environment. I'm switching the work directory, okay, to survival analysis. Okay, if you are new to Docker is pretty straightforward. And maybe later on you might decide to cover Docker as a full course. So we'll copy the requirement.txt to the current. So the reason why you're having this dot is because we want to copy this requirement.txt to this work directory, okay, which is like the current working directory in our Docker environment. Okay, we are going to actually run pip install, no catch the requirement file which we just copied. Once that is done copying, once that is done installing rather, we are going to copy the rest of our code. Okay, we are going to copy the rest of our code in this current directory. All right, we are going to copy everything in this current directory to the current directory we have, which is our working directory inside our Docker. So we are going to kickstart this Docker file. If you have to run this, run this image, you are going to kickstart it with ubicon app.apy:app. Okay, we are going to pass in the host. So if you want to run this, let's say locally, when I mean locally, like if you want to run this on your terminal rather, you are not going to have this separated, you are going to have it with space. But the way Docker CMD works is that each value, instead of separating them with space, okay, what I mean by space is this. Let me show you. So this is what I mean. If you want to run this, is definitely not going to, okay, is definitely going to be like this. So maybe you specify ports, okay, you have 8,000, okay, and you have this. So this is how you might want to run the whole thing. But because we are using Docker CMD, okay, so you might want to just run ubicon and run it this way. It's going to run. So, but because we are using CMD we are running this in the Docker environment. So we are specifying the host and the port as well. So this is what we want to run. We want to run our app, which is like the app object we define in our API. So, and this is actually the folder that is app, okay, app, then .api. So we are actually using this to get the API script and of course the app object which we define inside our API script. So that's what we're just doing. Okay, at the end of the day, we have a Docker file that we can just do Docker run. Okay, so let me try this once again. That we can just do Docker run. Okay, now taking a look at this, what we are doing is that I'm calling this interactive, that I want to run it in an interactive fashion. I can do mount. Now the reason I'm doing the mount is because I want my Docker, okay, and my local machine to interact together. So that's why I'm using this mount. Okay, so I'm actually getting my present working directory, okay, which is like source. The target, okay, is like my working directory inside of my Docker. Okay, the type is bind. So this is like I'm binding the mount. Okay, the port. So the port in my Docker, okay, is 8,000, and my local port I want to point it to is let's check once again. Let's check once again just to confirm. So the port I want to point it to is actually port 80. Okay, port 80 in my Docker, port 8000 in my Docker. Then I'm pointing it to point 80 locally. Then this is the image tag which I want to. This is like the image tag which I want to run. Okay, but before this, the first thing you might want to do is to first of all call Docker build. Okay, when you have a Docker file, you definitely want to do something like Docker build. Okay, so when you call Docker build, we can just do survivor. Don't mind this prediction or this autocomplete survivor model. So if you check this, you actually notice that we need to call the tag and the current directory where our Docker file is located. Okay, so I'm going to do doc model 0.1. That's my tag. You can do latest. So I say you should actually check this current directory. Before we do this, I just want to be sure that I'll copy this code. I'll close out of this. I want to be sure I'm actually in the right directory. So I'm actually in this survival analysis directory. Okay, if I do ls, I should actually see that my Docker file is in this. Okay, my Docker file is in this directory, so that I'm sure when I'm running the code. So let me paste this again, and I'm just going to run it. Okay, it's building. The essence of this T flag we passed here is just to tell it this is our tag. So it's building my Docker image right now. Okay, this might take some time. This is the first time you're on this code, because it wants to make sure that it actually gets Python or this official Python image is going to perform all of these steps. Okay, when you call this Docker build, it's going to perform all of these steps. Okay, but because I've actually done this before actually recording this video, okay, so that's why it's a bit faster than what you might expect. So after we've done Docker build, we are going to then do Docker run in order to run this. Let's give it a few seconds. Once again, make sure you have Docker installed to be able to run this code. If you don't have Docker installed, get Docker installed. Another thing you might want to do when you get your Docker installed, in order to have this successfully run on your PC, if you're on Mac, come to preference. Okay. Okay, if you're on Mac, come to preference. Okay, you have to open your Docker environment, come to preference. We'll come back to this. I just want to show you something. Come to preference. If not, your Docker might be crashing. Come to resource, okay, and make sure that your memory is actually 6 gig and above. If not, your Docker might tend to be crashing, okay, because Docker needs enough memory to be able to run, especially when you are now doing something like you're running your Docker compose and all. But then I will advise you just to come to this resource section and make sure you have Docker to actually have access to like 6 gig of memory. So I'll cancel this. I'll just close out of this. So this is still trying to get installed or get built. Yeah, or student built for a while, because we need it to close it. If this is taking too long, I can just switch, okay, to the other parts where, okay, let me try that. So I've actually built that image before, and let's do it. So Docker run. Okay, Docker run IT. So I'm mounting it now. Once if this is done building, all right. Instead of calling survivor prediction colon 0.1, we are going to be calling survivor model, right? Which is like the tag of our Docker image we define right here. So that's what we are going to be calling it. But because I've already built the image previously, we can still leave this to continue building. right? Because it's taking longer time than expected. Okay, I can just run this image right here that I've already defined. So let me just run it. Okay, so it should run and it should actually start up or kick off with this command. Okay, let's see. So let's do it. It's going to run in an interactive mode because I specified this -it flag. It should run, but I don't know why it's taking too long. Yeah, now it's off, and actually it's actually open on our port 80 because we've actually asked it to map port 80,000, okay, to port 80. I can just copy this this URL and come to my browser. I'm just going to run this and we are going to see. Okay, let me do this once again. Let me just do my. So that's like basically what we are specifying here as our host. You can change this to 127.0.0.1, which is like our local host. Okay, so let me just do 80 right here. Okay, why? 0.1 6,000. Oh, okay. So sorry, I think I actually made a mistake. So this port, okay, this is our Docker port, okay, which we are opening, and this is the port. So I guess I can change this back to port 80 instead, okay. And this is actually the port on our PC, okay, which is like on our local PC. Apologies for that once again. I think that was like an oversight from my hand. Okay, so this is the port on Docker. This is actually the port we pointed to. So what you are seeing right here is the port that is currently running on Docker. Okay, then this is like port 8000, which we actually open on our PC. So this is like port mapping that we did with Docker. So instead of port 80, it should be 8000. That's what I mean. Port 8000. Sorry. So this is the root directory which we actually pointed to, and we can go to docs because Fast API helps us with automatic documentation which actually follows the Open API format with Swagger. So these are just the two endpoints we define. This is where we have our prediction, and as you can see, with the help of the schema we define, we can actually see the payload which we should be passing to this predict endpoint. Of course, this is like the first place we go to. This is just like the root directory we define. So you can see all of these things getting logged, the request getting logged. So we are sure that we are running this. We are actually making this inference, so we want to perform inference now, okay, with the Docker container. So we can try this out. When you try this out, try to just change the values based on your knowledge on Pysurvival with ANALYSIS has actually done, okay, and passing some of these different values. Now, I'm just going to execute this because I don't want to pass in any value, and it should still give me, it's performing the inference. So it's performing the inference, and it should give me a response. Good. So this is actually my prediction. All right, my SVA and my risk. Okay, I'm not passing in any value, so we might not be getting the exact or the correct values for some of these predictions we have right here. But then I just want to show you to let you know that the model or the endpoint that we define works correctly. Okay, let's come back to this, and as you can see, we have some of these things which were things that are actually asked to be printed when there is a payload. Okay, so this is actually still getting viewed. I'm going to cancel out of it because I don't want this to continue building, since we already have an image that we built before now. Okay, so let me just close out of this. Let me shut down this Docker container. Now I'm just going to do Docker PS to actually see if there is any container that is currently running, I can see that we've already successfully shut down this Docker container that we spin up earlier. Now, a more convenient way of running Docker, okay, will be through Docker Compose, and I bet you a lot of times you want to use Docker Compose for quite a lot of things, because when you have multiple services now, okay, you want to use Docker Compose. Let's say you are using database, okay, you have other services, you want to use Docker Compose in order to define everything, so you don't have to be running Docker run for each of the image that you have. You just want to write everything, just Docker Compose to format everything and just run it together. Okay, so we're going to be using Docker Compose to spin this up. Now, I've defined everything that needs. I've defined the version, then the services. The only service I have here is my app. So I'm specifying build because I want to build with my current Docker file. I'm doing this port mapping. All right. So this port mapping now, the first port, and I think this is something I missed earlier. The first port you are defining is the port you are mapping to on your local machine. Okay. Then the second port is the port you are opening in your Docker. All right. Then I'm doing volumes. Now, initially, if you come to this place, you will notice that we actually specified our volume mount, okay, right here. Now, in this place, what I'm just doing is that I'm mapping this like my current directory. The first directory is your current directory. The second one, which is separated by your colon, the second one is the directory on your machine. In your Docker container or your Docker environment that is inside your Docker. Okay, so I'm mapping these volumes together. The reason I'm doing this once again is that I have data. I want this data to be shared. All right. For instance, if this data, okay, if it is not in my Docker environment, that is inside my Docker, I want Docker to look into this particular folder to get customer_churn. Okay. At the same time, I want whatever it is being created in my model path inside my Docker, all right, in terms of artifacts, okay, to get created right here too, so that I have this saved. So this is like a way of getting an output from my Docker or from my Docker environment. So that's why I'm doing the volume mount. Okay. Now, basically, the only thing I just need to do with this is just to call Docker Compose. Okay, I'm going to call Docker Compose. Docker Compose up will do the magic. Okay, it will only spin up this. So let me just do Docker Compose up. It's running the container already, or it's running the Docker Compose already, and it's just making use of this file that I've defined. Okay. There is just only one service. So I have survival analysis app 1, and that's the only thing. It's done. So we can come back to this place. I can just close out this again, open, and just do 1.7.0.0.1 port 8000, and there you go. So we have this once again. Initially we actually defined this with our Docker file. Now we are using Docker Compose to actually spin this up. This comes more in handy when you have multiple services, like I've mentioned before. Now, that's basically everything when it comes to reproducibility. You can share this, the image you built. Okay, you can actually publish it Docker up to your container registry, and have maybe another person in your organization pull that same image, and you can spin it up, and the container would run very fine. Okay, cool. So let me just exit this container. I don't want this container to keep running. Okay, that's basically everything. Now, the other thing I didn't talk about is I have a git ignore, then I have a docker ignore. Now, these are the folders, okay, that I actually put all the folders and the files that I don't want to be copied, all right, inside my Docker environment. Remember, when you define this Docker file, remember I'm copying everything in my current directory, that is everything in this place, to my working directory inside Docker. Okay, So because I don't want some files like git ignore, okay, Docker Compose, I don't want them to get copied inside my Docker environment. Okay. That's why I'm making sure that I define a a Docker ignore. Okay. That's the essence of the Docker ignore. Okay, so that's basically everything. We've seen our app running. Once again, we can do Docker Compose up. If you come to this place, you have your predict endpoint where you can pass in the features. Okay, where you can pass in the features. Okay, the features for predicting our SBF and our risk. Okay, these are the features. So you can pass in the feature or the respective values and test out the endpoint. That's basically what we've done. So what we've done in this schema is to define the features once again. I'm just reiterating this, and of course Pydantic helps us easily. We can actually specify the data type of each feature. Okay, that's for us to really make sure that our data validation is tight, because you don't want to run into any issues in production. So once again, I'm shutting down this container. Now from here we move to, we can, in case maybe you are using this in the organization, you want to of course push it to your repository. Okay, so it can actually be your git add. It's not a good practice though. You can do git add all. It's not always a good practice. Just do git add all. If you had everything, then you can do git commit, provide a commit message. The best, let me say, a good approach will be to specify to add each separately and commit each separately, because that makes tracking your code changes much better. Okay, so we've talked about everything on packaging. Let me go back to our slide. So basically, we've talked on scripting and packaging. We've talked about reproducibility. I've talked about, okay, you can push your code to your repository. Now let's talk about infrastructure provisioning before we actually take. So I've actually pushed mine to the repository. So right here, I can just pull this to my Azure environment. Before we actually take this to our Azure environment, I want to make sure that we actually provide that infrastructure first. So we are going to do kind of infrastructure provisioning with Terraform. Now, coming back to this place, you actually notice that I find a folder called Terraform. I created a folder called Terraform. Inside Terraform, I have main.tf, I have outputs, and I have providers. Now, when you talk generally about Terraform is one of the tools that you find a lot of operation personnel use a lot. Okay, so then the first thing I want to do, okay, I will point you to this directory, this resource right here. This resource is really helpful. The first thing you want to do, okay, maybe for the first time you want to actually make use of Azure, you want to have your Azure CLI installed. I've actually installed this with my brew. Okay, you have to log in, right? After logging in, you have to set your subscription ID. So your subscription ID is gotten once you actually do your AZ login. Your AZ login will pop a prompt in your browser, okay, for you to actually log in. Once you log in, Azure will provide you with some with these details right here. From here, you can actually get your subscription, okay, your subscription ID. You can get your subscription ID here, and your subscription ID you are going to set with your AZ account. You set the subscription, and once you are done, you actually have to create a service principal. So in other things, it's like a service principal is like a service account, an account that also makes request. In other cloud environment, I think you need to like something like service account or something. Okay, so it's basically just helping interacting with all the services on behalf of Terraform. It's like the user, okay, acting, interacting with this Azure project, okay, on behalf of Terraform. So you have to follow this. Just use this line of code in order to actually create a service principal. Once you are done, you get this app ID, display name, password, and tenant. Now, once you are done generating this, what you want to do is to export this in your environment. Okay, once you export this in your environment, once you are done exporting this in your environment, these are the values you obtain from this page. Once you are done exporting it in your environment, you can actually get started with Terraform. Okay, now for you to get started with Terraform, the thing is Terraform have what we call providers. Now, Terraform providers are basically like services that you can actually connect to. Okay, providers are like infrastructure to actually meet users. It is more or less like vendors, basically. So you have a lot of providers. You have AWS, you have GCP, you have Azure. So here we are going to use Azure. Now, this is not really a Terraform video because Terraform, for you to really understand Terraform, it's not that hard. But of course, by watching this video tutorial only, I might not give you an in-depth understanding on how to go with Terraform. Okay, now the first thing I'm doing is I'm calling Terraform. Now Terraform, the way it works, it's declarative in nature. So I just need to like declare some of these things: Azure RM, then the sources HashiCorp, Azure RM. I'm actually calling the provider. So what I'm doing here is like the required provider and the required version. So this is like the version for this is like the version for my I'm calling for my Terraform. The version for my provider is what I have here. Then I'm actually calling the provider. I'm setting the necessary things like my virtual machine, or these are like default I want to happen to my virtual machine. So I'm actually defining some of those things here. Shut down gracefully, skip shutdown, force delete. So like things like delete OS disk on deletion. That is, I want my OS disk to be deleted once I actually delete my virtual machine. So these are like some basic configurations you want to set. Now, after you've done this, okay, the next thing you want to do is you want to call Terraform init. So by calling Terraform init, Terraform okay, so I'm not actually in the directory. Let me do ls. So I have to feed it to Terraform. So once I'm in this Terraform, I can just do Terraform init. Now, because I have this Terraform HCL, okay, you might actually not. So it's going to instantiate and going to create some sort of Terraform script for me. It's going to create some couple of other files here. So you have to like wait for a while for it to actually get set up. Once I call Terraform init, from there it's going to download my provider file. So that's where it's going to be stored. There will be a folder that will be created with my provider configuration. Okay, more or less like a package for this Azure RM provider, for Azure provider. Afterwards, I'm going to come to this place. Why this is actually going on? Okay, why this is going on? Let me just take this down. Why this is going on? I'm going to define a resource. Now, if you are very conversant with Azure, there is something called resource group. Okay, so the first thing I want to do is create my resource group. Now, there is a format I actually realized with working with Terraform generally. Now, the first thing is that you separate. This is the resource name that you want to create, okay, and this is actually the provider. So you usually separate Azure when you are creating a resource. You first of all write the name of the provider, then you have an underscore, then you call the name of the resource. So here we have resource group. So we first of all want to create a resource group. We name it RG. So this RG, okay, is like a variable name in Terraform. So this name can be anything because we are going to be using this name to actually reference this particular resource group we are creating in Terraform. Is within Terraform. It doesn't have anything to do with what you have in your Azure portal password or anything. Okay, so we have location. So I'm actually using UK South for location of my resource group. Then the name of my resource is Survival Analysis Resource Group. So this is the name that is going to appear in your Azure portal. Okay, from there, I'm actually creating another. So this is like where I'm starting to declare the infrastructures that will be provisioned. So I have, I will first of all create a virtual network. That I name it VNet. Okay, then this is the name. Okay, virtual network. I will define the address space. Okay, now the location, I want it to use the same location as my resource group. So if what I just need to call is this. So a common way which I used to also remember this is to just call this the name I actually defined here dot. Okay, dot rg. That's like the name of this variable. I call this a variable really. So of this resource group I actually created right here. Then dot location. Okay, so this should be quite very similar. Let me say more straightforward if you come from background of working with just when you're calling some object that you defined before, or maybe Python when you're calling your methods. Okay, then the resource group name is just similar way. Then I actually need to define a subnet. Okay, I will still call, so it's still under resource. I will have to call Azure RN underscore subnet. Subnet is the name of the resource. Then I'm naming it subnet. So I actually name internal subnet, and you have the resource group name, the virtual network name, which is like what I actually created here. So I will still call Azure RN virtual network, which is what we have here, dot VNet. Then because I need the name, I will just use dot to also get the name. Now the address prefix. Now so this thing, okay, this is my subnet. Don't forget, it doesn't need to be too far away from your address space here, which is created in your VNet. Okay. Then I'm going to create a public IP which I want my instance to use. So I'm naming this pub IP. Then I'm actually calling the name of the resource group, the location, but at the same time the allocation method. I want this to be dynamic, not static. Okay. This IP address will actually get created after our resources, that is maybe our VM has gotten created. So after our resources have been created, that's when we'll get to know this public IP. All right. The net interface, I'm going to create a network interface, and still the same thing. I call the resource. Now the only thing that is different here is that I have an IP configuration here, which where I'll be calling the subnet ID. Okay, the public IP address and the private IP address allocation. I want this to be dynamic as well. Then the last part, okay, which actually happens to be where I'm defining my Linux virtual machine itself. So I'm actually naming it Linux VM. Then I will actually call some of this. I'll also define some couple of other parameters. Naming this Linux instance. The resource group, we are actually creating this Linux machine. The location, okay. This size, I actually want a standard D2AS pivot for the admin username. I want to create like the default username I want to be able to, like, when I'm accessing my instance. So I want the name to be Azure user. Maybe when you are conversant with maybe AWS, you are creating a machine or maybe not machine within the AWS environment, it might sound like Ubuntu. So here we have Azure user. Now we'll come back to this custom data because I'm actually defining it's more or less like a cloud thing. Okay, that is something I want to automatically, I want to automatically run once my resource is getting created. Okay, that is once this virtual machine has gotten created, I want this script to be run. And we're going to come back in a couple of minutes to talk about what actually happens in this script, because what actually happens in this script is like something that also gets a lot of things started. Okay, let me come back to my menu. So here I'm going to actually define admin SSH key. Now, in order to just define an SSH key you want to use, okay, why this is still getting created? Let me come to this place first. Let me clear this. Now, you are going to want to do SSH, all right, and SSH you are going to want to do keygen. Now, you are going to want to do is to actually generate an SSH key. So you are going to do SSH hyphen keygen, and you are want to generate ED with this particular in this particular format for Microsoft for Azure resource. Now, once you are done creating this, okay, you can actually move it to your .ssh file, right? When you are done creating this, move it to your .ssh file. If it's not there, then you can actually reference it. So I've actually created mine, okay, and I actually name it Linux Survivor instance.pub. There will be two files that will be created for you. Let me show you very quickly. All right, so kicking up from where we left off, I'm just going to do ls, all right, in order for me to view the SSH keys, which I have already. So I'm just going to do ls, then this tilde /.ssh. Now, as you can see, I actually look at what I'm using here. I'm using Linux Survivor instance .pub, and as you can see, I have two of that. I have this Linux Survivor instance, okay, and Linux Survivor instance.pub. So is it .pub? I'm going to make sure that you are using as your public key, because that's the public key. You are going to have one on your PC, then you are going to have one which is like the one you want to actually provide to your instance. Okay, you're going to want to also have your OS disk to be caching to be read write. Okay, and of course you want to have your storage account type to be standard LRS. Now this way you are providing your image reference, the source image reference. This might seem how do I get to know this? How do I get to see this? Okay, you can actually go to your Azure portal, okay, and you can browse through the couple of images that are there to actually get this offer. Then you have to define this SKU. The SKU is like the version of the Ubuntu I'm actually using. Okay, you see I'm actually calling an Ubuntu server right here, so it's actually the version. So I'm using this like 20.04, right, LTS, which is actually Gen 2. Then the version should be latest. Okay, that's basically everything when it comes to defining our infrastructure. We define a source group, we define a virtual network, we define a subnet, we define a public IP, we define a network interface, we define a Linux virtual machine, which is like our main VM, which is what we really need. Okay, once you're done, you want to also check out output. So basically what I'm outputting here, this is like a way to actually print something in your terminal or get to know some information from some of the resources you'll be creating with Terraform. So I'm actually naming this is an output. I'm actually naming this Linux machine IP, and the value I'm passing to it will be I want to actually know the public IP address of my Linux VM, which is what I'm creating. So we can't get the public IP of this virtual machine unless it has been created. So after it has been created, I actually want to know the public IP address so that I can SSH into that machine. Okay, now basically let's just now talk about this initial setup.sh. Now this initial setup.sh, you will notice that in my main file, I'm actually calling this to be a custom data. Maybe when you're using Terraform with AWS, this might be called user data, right? Maybe it was something that you define with templates, all of those things. Now, basically, I want this. This must be must be 64 encoding kind of thing, or base encoding that you are going to be using. So I'm actually using 5base64 to call this initial setup.sh. Now, what you have inside this initial setup.sh is just an sh file. The first thing I want to do to my instance is that I want to do sudo apt update. I want to update it. I want to get this CS certificate and some of these other packages. Now, I want to install Nginx. As I mentioned earlier, that Nginx is basically we're using for reverse proxy. So that's why we're installing Nginx. We're going to also, install Docker. Okay, this is where we are installing Docker from this place. So we are going to first of all use core. Don't forget that we already installed core in case it is not already installed in our machine. So we have to first of all install it. Then I'm using core to also get from this Docker repository or this. So I'm adding the official GPG key. Okay. then I'm actually adding this repository. This is where I'm actually adding Docker repository. Okay, so and from there I need to do sudo app update to my on my instance, and I have to do sudo apt install. I will install the Docker container.io and of course the Docker compose. So what I'm doing here is sudo user mode. I'm adding this user to the group of, I'm adding this Azure user to my Docker group, so that I don't need to actually do sudo docker when my instance is actually set up. Imagine when I was writing Docker the other time, you see I didn't put something like sudo. I don't need to put sudo docker to run because it's not a recommended way of using Docker. So you expect to like create a user. Okay, maybe that will be your normal computer, the user you're using to actually interact with Docker. So this is actually an effective way of running Docker. Now, looking at this script, this is a script that we can actually go into our instance to be running, one line after the other. But because I actually want to make sure that we are provisioning our infrastructure with Docker and Nginx installed. Okay, that's why we are doing this. This will actually save you from a lot of issues because you have all the configurations. You have all the configurations defined already, and everything will get set up for you automatically as you are creating your infrastructure. So you don't need to actually SSH into your instance and start installing all of these things one after the other. So you can actually define everything. Now, this will make it easy for you in case you're actually moving to another cloud provider. Okay, because you don't have to maybe you've forgotten or you need to remember something that you installed previously. So you have everything written out already. Okay. Initially, I noticed that the log file that was created before had an issue. That's why it didn't get to initialize my Terraform. So let me cd back to Terraform, and okay, so I'm actually in the Terraform. You have to make sure that you are in the Terraform folder we created. Another thing you're going to want to ensure is that you have Terraform installed. On Mac, Terraform is as good as saying brew install Terraform. As simple as that. Okay. On other machines, you want to look up Terraform documentation on how to actually install that. Now, what I'm going to do once I'm in this folder where I actually define my providers.tf, because this is like what Terraform will use to actually initialize. Okay, make sure you are in the same directory where you have your providers.tf, or maybe wherever you have your providers or declared. Okay, you have to make sure that you are in that folder. Then I'm going to just call Terraform init. It's going to initialize, and you're going to see some couple of other files get created right here. Okay, it will pull the Azure RM, which is like the package is going to use to interact with the Azure infrastructure. So it's going to pull down a couple of those things, and we're going to see some files here shortly, and a folder called Terraform again. In case this might seem confusing when the folder is up, feel free to change this folder name, okay, maybe to infrastructure, or maybe to anything that you think aligns with whatever you use in your organization or you want to use to just practice. Okay, so let's give this some couple of minutes to finish instantiating. Once that is done, okay, we want to do Terraform plan. Okay, then from there we'll do Terraform apply. Then we'll go to our Azure portal to check it out. It will have gotten created. So let's just give this some minutes to finish getting the requisite packages. Okay, this is taking too long. Don't know why. All right, so we have the Terraform initialized already. It took a while, but then it's not supposed to take longer time if you have a fast internet connection. Now that we have our Terraform initialized, okay, as you can see, you will see that there is a .terraform folder that will be created, and when you check, you can actually see a Terraform provider Azure plugin that have actually been downloaded for you. Then you have this terraform.log. So from there we can start using Terraform to check things out. Okay, don't forget your Azure credentials. Make sure that they are actually in your current environment. Make sure those setup are there before you proceed. So I can actually try by saying, first of all, I want to do something like there are a couple of commands when it comes to Terraform. There is Terraform or FMT, and FMT basically helps you. So let's say that you so let me take this down a bit. Let's say I have something like this. Okay, let's say I have something like this that is not well aligned. So Terraform FMT is similar to from you just want the format. So if I just call FMT, okay, let me check ls. So provider main.tf. I'm not actually saying my main.tf. Okay, don't say. I want to check. So let me just close this and open it again. I'm actually supposed to see my main.tf. Okay, cd terraform ls. Okay, I don't know why. So let me just take this out. Let me move this out and let's do ls. Okay, and let's bring back the main tier. Move. I want to do ls again. So let's just do the Terraform plan. Let's do Terraform plan. We should be able to read our main outputs and providers. So let's see. All right, so our Terraform plan actually works. It's worked. So now you have all the infrastructure that we've, all the resources rather that we've actually defined in our main .tf. We have everything right here. Okay, so you can see things. Anything you have known after apply means it will actually get applied, or you'll be able to. Its value will be attached. Okay, once we the infrastructure has been created. Okay, so from here now we can actually do something like Terraform apply, and Terraform apply will help us get the infrastructure provisioned. Now when you do Terraform apply, it's going to ask you just going to like confirm, so you have to put in yes or no. But because I just want this thing to just go straight forward without prompting me to enter yes or to enter no, I can just do auto approve. Okay, by doing auto approve, I don't need to. It's similar to when you want to install a package in your terminal and you decide to attach the Y flag. Okay, so that you don't need to be prompted to enter yes or to enter no. So that's just why I'm passing auto approve. And with Terraform apply auto approve, the infrastructure is going to get created. So let me create the infrastructure now. Okay, the first thing you're going to note is that you will have a new file created called Terraform state. So that's your TF state. So TF state file is going to get created. You're going to see .log here, and you're actually going to see TF state here. So the infrastructure is getting created. So let's give it some time. Now the thing is, when you scroll up. So now look at, when you have plus, okay, it means that the infrastructure is getting created. Now there are other things like, okay, maybe when you want to delete an infrastructure, but for this you want to create an infrastructure, so you actually see plus right here. Now we can actually destroy the infrastructure once again, once it has been created. Now mind you, if you want to do this, maybe you don't want to use Terraform seems confusing, you don't really need to do much, or just go ahead and create a virtual a virtual Linux machine on Microsoft Azure. Okay, and make sure you have your public key or your private key, maybe the one you're going to generate or create a new one on the Azure portal. All right, and from there you can just SSH in. So while this is getting created, now look at it, our resources are getting created. Okay, we are creating our resource group, or the public IP, virtual network, subnet. Okay, it's getting created. Okay, our network interface is getting created, and now it has gotten to our virtual machine, and our virtual machine is actually getting created right now. Okay, so let's give it a few moments. It's going to get created, and it's going to run our initial setup script. So all of these scripts are this script and each lines of code here we actually run once our virtual machine, okay, is done creating. Yeah, so give it a few seconds. It's going to finish this process, and it's going to output. All right, it's going to output what we ask it to output right here for us, which is like our public IP address, which is what we need in order to SSH into this machine. Okay, so it's actually going to do that. It's going to output that for us once this is done creating. Okay, Terraform is really a nice tool, or if you actually realize that you deal with, or you really want to like have a repository of managing your cloud infrastructures. Okay, so Terraform is a nice one. So let's give this few more seconds to finish creating. I believe at this stage you should be running the initial setup.sh. So any moment from now, the infrastructure should be done. Yeah, cool. So now we have apply complete, resources 6 added, 0 changed, and 0 destroyed. So actually, with this line of or with this code, okay, in our main.pf, so we actually deployed like 6 different infrastructures. Okay, now these are public IP address which we can use to SSH into the instance. I'll just open my terminal. Okay, so this is the old terminal. Let me just open a new one. Okay, now I can SSH into the Linux machine we've just created with my SSH with my iflag, okay, that points to the private key, okay, on my machine. SSH, okay, /Linux instance. Don't forget that it's actually Linux survivor instance. So let's go check it out once again. Okay, let's go check it out. Now, can you say public key? So the public key is Linux survivor instance. Now, so it needs to be. I want to confirm that you guys can actually see my screen well. So let me increase this. Okay. Now it's clear. So I'm actually calling the Linux. I'm pointing to the Linux survivor instance private key. Then, if you remember, the name or our username is Azure user, and you have it right here now. So this should not be the correct. So at our public IP address that was just created, so I can do enter. So, and as you can see, it's prompting me to actually type yes, so that the key can actually get configured on my PC, and I can talk to my Linux machine. Look at what we just created. So I can actually talk to the Linux machine we've created with Terraform. Now, when the first thing I want to confirm is if the script, this init script, which I actually used to install Nginx, if it's actually installed or if it's run correctly. And maybe just a simple way of checking is just to run Docker. So let me type Docker. Oh, can you see? So Docker gets installed by using this by Terraform, using this script to actually run all of this. I'm sure Nginx as well must have gotten installed. Let me confirm that by doing systemctl. Okay, I want to do systemctl. I'm going to call status Nginx. Look at. So we have our Nginx service currently running. Our web server is running. So that's what we're going to use for our reverse proxy. So let me quickly close this, and which means that we have our Docker installed already. We don't need to install Docker. We don't need to install Nginx. The next thing we need to do is just to so let's now clone our repository and get our model running. Okay, so that's like introduction. So I can just do another directory. So because there should be nothing yet. So make directory survivor. So I can just do survivor. I can cd into survivor. Okay, now I'm in survivor. So let me go to our repository. If you pushed your code to your code repository, you can just come here, copy your just the way we actually cloned it the other time. That's what we're about to do again. I can now do git clone, and I can do this. So git clone should okay, so it's going to prompt you for this. Then it's going to prompt you for your password, depending on kind of the way you've set up your git. I'm just going to pause this so that I can actually get my key, my password, which is like my secret key, and I'll come back. Okay, so I'm going to get this. I've gotten it already. Now we have, so when you do ls, you actually see our survival analysis code got directly into our Linux environment. Now, in a more proper setting, maybe as we move on, these are some things we want to keep iterating on. For instance, we don't need to be doing this manually. So we want to have a CI/CD pipeline that automatically helps us deploy our model. Okay. Then later on, we are still going to be talking about monitoring and quite a lot of things. So this is just like, so in terms of ML of maturity, okay, in your organization, this is just like, helping you get started very quickly, and that's what we are doing. Okay, so let me just open my survivor. Let me cd, okay, into my survivor analysis, and I can do ls, so you can see everything right here. Okay, now another thing you want to do is, now we have a script called fast API Nginx. I can do cat, okay, fast API Nginx. So this is where we define our Nginx more or less like service for our service, okay, more or less like a file that we want to use for reverse processing. Okay, now if you notice, this server needs to be changed. So this was the previous one I was using. It needs to be changed to the current public IP address. So what I'm going to do, okay, is that I'm going to use Nano. Okay, I love working with Nano a lot. We're going to use Nano, okay, and right here I'm going to come to this place. Okay, I'm going to come to this place to actually so let me come back to this place to copy, and I'm going to come back to this place to paste. Okay, so it's not copying properly. 20.08. So it should be 20.108. Okay, 0.9.26. All right, we are listening on port 80, and we are going to have this proxy pass to be equal to, where our model will be running, or where our web application will be running, okay, on our Docker instance. So I can just do Control O, save this, Control X, okay. Then I can clear this. Now what's left for me is to move this particular fast API Nginx. Okay, I want to move it to the proper folder so that it can actually get Nginx can actually read this before I launch my server. Okay, so I want to. Okay, so what I just did basically was to copy this, clicking off from where we left off the last time. Okay, so we're about copying our Nginx, okay, our fast API Nginx down to site enabled inside our Nginx. So that's what we want to do. I did that previously when actually first this recording. So what we are just going to do is to copy this file. Okay, this is our fast API Nginx, which we modified the other time to include our current public IP address. We are going to copy that file to our site enable so that Nginx can actually get to read it. So let me do that again. So I'm just going to copy it because this directory needs a kind of sudo privilege. So I'm going to make sure that I actually pass in my sudo so that I can actually copy into this directory successfully. So I'm going to do sudo and I'm going to copy this. Now I can actually do systemctl, okay, restart. So let me restart my Nginx. Restart Nginx. Systemctl restart Nginx. So okay, because we are not actually using we are not using password. Let me just close this and let me try to do sudo instead. Let me do sudo. Okay, now so it works. So we are not using password. So just passing sudo will do that with the root privilege. Now the next thing I need to just do, look at this, I'm still in the current directory where I have my Docker Compose file. So I can just do Docker Compose or Docker Compose all. Now don't forget that while setting up our infrastructure, we already installed Docker and Docker Compose. We already installed Nginx, so we're not doing that. So I can just do Docker Compose up. It's going to build that image. So when I left off where we left off the other time, I actually have to build the image. So just need to run Docker Compose up. It's going to build the image and it's going to start running. Now it's currently running on this particular port 8000 in this particular URL. Now this is localhost, right? We can't access it. So we need our public IP address, okay, let me come back to this place again. We need our public IP address to be able to access the model, or to access what we deployed, to access the Docker container which we are currently running. So I'm going to copy this and I'm going to come to my browser. Okay, so I'm going to open this new tab. I'm going to paste this and I'm going to do port 8000. Okay, wow, now this is up. So as you can see, we've successfully deployed our model. So when you go to docs, you can actually see the documentation for our model. And this is what we've been able to achieve by using Terraform to provision our infrastructure on Microsoft Azure, and at the same time, using Nginx for reverse proxy, and using Docker, okay, to spin up inference server. Okay, so yeah, thank you guys. I believe we've been able to cover this quite long, but I believe we were able to actually cover a lot. I hope you understand this. If you have any questions, if you think you have contribution as well, of course, you can feel free to drop your comments in the comment section, and of course, you can always reach out to me and Eniola anytime. So we've been able to cover scripting and packaging, versioning, and reproducibility. Though we didn't really do much on versioning, but because I believe I really assume that Git should be a prerequisite before coming to this place. So reproducibility, of course, we actually package our model with package our inference server with Docker. We actually did infrastructure provisioning and production. Now, in other contexts, okay, now let's say you are using experiment tracking tool like MLflow, weight and biases, Neptune, Comet. There are quite a lot of them. Some of them which provide you with model registry. Okay, sometimes you might just want to like really deploy from maybe just create an endpoint from your model registry. Now, all of these things are what we are still going to cover later on, in order to like really give you different perspective, because when it comes to MLOps, the landscape is very, very wide. But there are quite a lot of ways in achieving certain things, but then you have to just stick with the one that works for you. So in terms of MLOps maturity, this is like stage 1. Okay, no full automation right here. We are not really dealing with quite a lot of automation, so we are going to get to that soon. Okay, but with this, we've actually been able to help you with these tools with Fast API, Docker, Terraform, and using Azure Cloud. We've been able to help you get your first model to production, especially when it comes to survival models. It's quite difficult a bit because unlike a normal scikit-learn that you can just quickly run, why this is a bit difficult is because it needs a C++ compiler. It runs on touch, so some of these complexities, when you try to like run it locally on your PC, you might have some sort of difficulty. But with Docker, it actually helps us to really encapsulate all of those dependencies together without. So we build something that is OS agnostic in code, but though our Docker still run on Linux. Okay, but we built something that was OS agnostic, which means that regardless of the OS you're using, if you have Docker installed and you run this, if you run this code exactly the way we actually walked you through in this tutorial, okay, you should actually get your survivor model up and running in production. Okay, thank you once again, guys. I'll see you next time. Thank you.